Hi students, we're going to go ahead and learn a new lesson. I'm at Rancho Cucamonga High School, so this is the main quad. Someone else is here. It's a Saturday. Get out of the frame. It's pretty empty. I came here today, Saturday, so that I wouldn't have to wear a mask because then no one else would be around. Okay. All right, I'm going to flip the video. By the way, my classroom would be in that end. It's if you follow that little corridor, I'm the second classroom on that end. Okay, so let's go up. All right, there's our auditorium. So here's that. We're going up these steps. It's artificial grass, by the way. It used to be real grass, now it's artificial, right? But then here's the zigzag, right? Crutches or wheelchair accessible. That's the office. So we're going up the steps to this auditorium, the Rancho Auditorium, right? So we came from there. They have artwork. I just noticed it. It's probably been here for a couple of weeks, probably since we started school. All right, that's where I'm teaching. I forgot a chair, so we'll make this quick. Here we go, let's pan out. So there's the auditorium. That's the east parking lot. This is the west parking lot. That's the library. This is your quad lunch commons area. That's the NPR. The football stadium's right behind there. You can see the lights. Right, we want Friday night lights back up. Okay, it's 2 minutes in, let's get to work. All right, oh no, this is good, I can keep it that way. All right, let's see. It's got a slight breeze, so we're gonna, again, try and anchor down. Okay, introduction to similarity. This lesson will focus on 3 aspects of similarity. First, the way you name it, the angle relation, and the side relations. That's it. Name it. Can you pair up the angles? And then can you write a ratio of the side lengths between the 2 triangles? Because remember, this is similarity, so they're not congruent. Congruency is what you did with your last math teacher. This is similarity, so one is bigger, one is small. So big, small. I'm under this corridor and I'm echoing. I don't know if I should shoot out, so we'll see how it goes here. Okay. So kind of show. There's not much writing. We're just going to be filling in letters. There's no numbers. Okay, here we go. We have triangle MNO, triangle WYZ, right? So there you see triangle MNO, triangle WYZ. Now, I started from the left, went up, and came back down. So MNO. WYZ. So this name is actually correct. So when they ask me to write a statement of similarity, they're asking the wind. Okay, they're asking me to write a similarity statement that declares all the congruent and proportional parts. So you have to make sure it's named correctly, because the assumption is, we're going to go over this, but M goes with W, N goes to Y, O goes to Z. And your arcs have to match that. Okay, so one similarity statement would be triangle MNO is similar to triangle WYZ. I started from the left. Notice 1 arc, 1 arc, 2 arc, 2 arc, 3 arc, 3 arc. So this order went 1 arc, 2 arc, 3 arc. 1 arc, 2 arc, 3 arc. Now, you could also start from the top, N. I could have gone N-O-M. So if I went 2 arc, 3 arc, 1 arc, right? I went top, right, left. You better go in that same direction here. 2 arc, 3 arc, 1 arc, or top, right, left. So Y, Z, W. Or you could have gone MON is similar to WZY. So this statement of similarity is everything. This tells you everything you need to know about the triangle. So if they decided to not give you a diagram or an illustration of the triangles and they just gave you this name, statement of similarity, and they gave you a few givens, that's all you need to know. And eventually we'll get to that. Not in this video. Okay, so now they're triangles, thus the only 3 pairs because it has 3 angles, so thus 3 pairs. All right, in similarity, the angle measures are equal. They're congruent, they're the same. All right, we don't have any numbers here. That'll be the next example. So here, we're gonna go ahead and label our pairs. So the one arc, remember, the arc symbol means that they're congruent or equal angle measures. Okay, that's what these little arcs are. 1 goes with 1, 2 goes with 2, 3 correlates to 3, right? Okay, so my one arc is letter M, and it's so hot out here that, oops. Okay, so M goes with W because they're both one arc, correct? Okay, next. N, I think I'm in a cement groove. It's the table's wobbling. Okay, so then 2 arcs, N goes with Y. It correlates to Y. I'm trying to move this. I'm trying to see why. I wouldn't see why the cement would be uneven. Yeah, it's still wobbling. And then, of course, my 3rd arc, O, goes with Z. So O goes with Z. So those are your 3 pairs of congruent angles. Put the arcs together because we don't have angle measures. Okay, but also notice, in terms of your naming, right? So say, for instance, we're just going to go with this one. Okay, we're just going to go with this name. So I'm going to rewrite it very big here. M-N-O, this similarity statement, right? We're going to choose that one. Whoops, W-Y-Z. Okay, for the sake of numbering, this is my first vertex. This is my first vertex in the name, right? First one. This is the second vertex in the name, and this is the 3rd vertex in the name, correct? So simplify this similarity. So in my name, first, middle, last name, kind of what we have. So first vertex, second vertex, 3rd vertex. First vertex, second, 3rd vertex. Second vertex, 3rd vertex. Okay, so what did I do? M goes with W. The 1s go together, M and W. The 2s go together, N and Y. And the 3s go together, OZ. So when you're given the statement of similarity, if you number 1, 2, 3, 1, 2, 3, it tells you everything you need to know about how they correlate, correspond, or what the proportionality is within the 2 triangles. Okay. Okay, statement of proportionality. This is going to be said and said and said for the next month and a half. Statement of proportionality is now taking your bigger triangle and your smaller triangle, whatever figure it is, and it's creating a ratio. Because remember, they're not equal. It's not like congruency. This is similarity, which means there's a scale factor that's not 1 between them. Is it 1/2? Is it 1/3? Is it 5? Is it 4/3? What is it? Okay, so you have a ratio. So what you need to decide here with the statement of proportionality is, do you want to go small, big, or big, small? What do I mean by that? You have ratios here. A ratio, top, bottom, top, bottom, top, bottom. So do you want a numerator, denominator, numerator, denominator, numerator, denominator? So one of these triangles is going to take the top position and one of the triangles is going to take the bottom position. So you just have to decide, and you're always going to get the same answer as long as you do it correctly. Do you want to go big, small, or small, big. Right, so we'll go big, small just for this one, and on the next example, we'll go small, big. Okay, so that way we'll do half and half. Okay, it's Astro Neil needs to help. Okay, so we're gonna go, I think we said big, small. So I'm gonna label, we're gonna take the big triangle and label it over the small triangle, just to be consistent. Okay, all right, so I'm gonna use colors again. Okay, so I'm gonna take this green, right? I'm just gonna label it. Okay, so if I come over here, this third side is right here, MN. So it's MN. I'm gonna come back and I'm gonna fill that in. Okay, but hold on. MN will correlate with WY. I wish I could. Here, I'm gonna switch the blue color just because that one's really light. Okay, so if it kind of looks a little different. Okay, we're gonna go blue here. I'll come back and I'll tell you what I'm gonna do there. Okay. Okay, so then the next bit is NO over YZ. And then the third, OMZW. My screen is so dark because the sun is, it's heated up the phone. So I can't even see. I'm trying to use my head to shade the phone. Okay, what am I gonna write up here? Okay, this is the statement of proportionality. What I'm going to put up above is going to reference what we named here. Because remember, the ones went together, the twos went together, and the threes went together in terms of your three pairs of congruent angles, right? Okay, how does it work for sides? So if this works for you, this 1, 2, 3, 1, 2, 3, and naming the vertices, the first two will go together. The second and the third will go together, and the first and the third will go together. And those are positions. It's not 12 and 23 and 13. It's 1 and 2 over 1 and 2, 2 and 3 over 2 and 3, and 1 and 3 over 1 and 3. So if you want to put a little comma there, you can. So we're talking about positions here. So when you look at your name, you don't need this illustration. We have it, but we didn't need it. If we didn't have this and all we had was this name, just that, everything I know about the triangle is right there. Because if you're able to understand first vertex goes with the first vertex, so whatever angle measure M is, that's what W is. Whatever angle measure Y is, so is N. Whatever angle measure O is, so is Z. Okay. Now also, I know how the sides correlate. The first two MN vertices create a side, right? Remember, 2 points create a segment, right? So even though they're vertices or vertices plural, right? We need 2 letters to create a side. So you have 1 and 2 MN goes with 1 and 2 WY, and that's what I have here, but there's my 1, 2. The second and the third position, or the second and the third vertex, gives me NOYZ. NO over YZ, and the first and the third, MO, and the first and the third, WZ, or ZW, gives me the third ratio. Okay, you better have 3 ratios because I have 3 sides. It's a triangle. Okay, so the next example, we'll go ahead and go into actually filling in and solving angle measures and side lengths, okay? All right, here we go. Let's see if, all right, you can look at the sky while I do this. You can't. Okay, working outside is actually a little difficult. Not gonna lie, inside my little room. It's so predictable. All right, I'll let you guys see. Oh, so you probably recognize the library. This is where you came to pick up your textbooks, right? Yeah. I'll see next time if they'll let me into the auditorium, and I'll go in there so you can see. All right, this is gonna end up being a long video because I'm gonna end up adding non-math content. Okay, so if you look over here, right, you would all sit here and have lunch. You would sit over there. The student store, oh, well, you can see the sign there. Student store. Yeah, right there, that's the sign. That's how you would exit, or I don't know, one was the entrance, one was the exit. Those stairs lead to the library up here, so that's where students would, that's where you would sit and study, where the books are. Downstairs, underneath that building is Mr. Cataldo, the computers. Digital, like digital film. Oh my goodness, I couldn't remember that. Yes. Okay, let's go back. Yeah, next time, Kenny, bring a chair. All right, I'm working my quads right now. Okay, let's see if I can see where we are. Here we are. Okay, so here's a triangle. We have angles filled in, so now I have 18 is a length of MN, 6 is a length of NO, X, that's what we're going to solve for. We're going to need to find the length of MO. The angle measure to angle M is 20 degrees, right? Angle N and angle O we don't know yet, although we kind of do. Okay, angle W, right? Angle Y is 88 degrees. Angle Z we don't have, but we kind of do. Okay, the length of YZ is 3, the length of WZ is 4, and the length of WY is Y. All right, let's go. Okay, write a similarity statement. You can write whichever one you like. I'm just going to write one of them. So remember, the similarity statement is where you declare, is it a quadrilateral, is it a triangle? In this case, it's a triangle, so I'm going to write a little triangle. And I'll just go with 1, 2, 3. So MNO, MNO, and go 1, 2, 3. Now the 1, 2, 3 are the arcs, and then it's also going to be the way I number them anyways. Okay, so 1, 2, 3, 1, 2, 3. If this helps you, great. But some of you, you don't need it. You just understand what I'm doing. Your congruency teacher taught you very well. Okay, we want to fill in the 3 pairs of congruent angles. Remember, you can go by the arcs or by the name. The 1s, the 2s, and the 3s will go together. So the first vertice, the second vertice, and the third vertice, and the naming is going to give me the pairing, right? Okay, so angle M is going to correlate to angle W, because 1, 1. Angle N will be congruent to Y, and angle O is going to be congruent to Z, right? The first, the 2, and the 3, we can also go by these angles. Okay, let's also fill in what we have. Notice, I have a degree for angle M. It's 20. I have 20 degrees. So if I have 20 degrees here for M, wouldn't that also, by similarity rules and congruency, that angle W would be 20 degrees, right? So I know that measure angle W is also 20 degrees because M and W are congruent, right? So if this is 20 degrees, this is 20 degrees. Okay, so now let's look here. I have 88 degrees is angle Y. That's 2 arcs. So you can either go by the 2 arcs or you can go by your 3 pairs of angles. Angle Y is congruent to angle N. So if Y is 88 degrees, N is 88 degrees. So the measure of angle N is 88 degrees. Okay, so if I fill that out here, all right, you know the triangle, sum theorem. What do all triangles add up to? 180 degrees. Always, 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 right? So if I have 88 and I have 20, what is 88 plus 20? Well, 88 plus 20 degrees is 108 degrees. Oh, sorry. I told you I can't. It's so bright out here. So if all triangles are 180 degrees and I have 108 degrees spoken for, if I want to find out what the other degree measure is, it's going to be 72 degrees. So that means angle O is 72 degrees and angle Z is 72 degrees. Because of the triangle sum theorem. These three angle measures, right, the interior of the angles should be 180. These three should add up to 180. Yes? Okay, so that means measure angle O and measure angle Z are both, what did I say, 72 degrees? 72 degrees. So we're very capable of finding our angle measures. Notice I'm not using that many markers because it's just, everything's so much more difficult right now because I'm not sitting. Okay, statement of proportionality. Remember, you can do remember, the first and the second vertex, the second and the third vertex, the first and the third vertex, right? So if this is your 1, 2, 3, 1, 2, 3, that's how you pair them up. Now, you just have to decide, do you want to go small, big, or big, small? We went big, small on the first example, so let's go small, big. Okay, so I'm going to go, we'll go green. So you know what, on this one, I'll color code. Let me just make sure I get the right side. So we'll go green. So let me pan up and let me label correctly and then we'll fill in. Okay. But yeah, I think I did that color next. Yeah, this one's not gonna come out as nice. Okay. Okay, so we will go small, big. Okay, small over big. Okay, so if we do that, the first and the second vertex is WY over MN. The second and the third is YZ over NO. And then the first and the third is ZW over OM, right? Whoa, sorry. So remember, you need to understand the similarity statement. You have to understand it. If you understand just this and you're not given any of this drawing, you don't need this. They would just have to put you to the side and say, oh, this angle degree is this side length is this, and you should right away be able to jump into the statement of proportionality. And from there, now we're going to go ahead and substitute from the triangle. So we're going to put in our givens. Okay, all right, so for WY, what's declared? Little y. For MN, it's 18, right? YZNO, 3, 6. And now you just have to be really careful because sometimes students accidentally will put 6 over 3 because if you're going small, big, you just have to remind yourself you start from the right and go to the left. This is the top number, this is the bottom number, okay? And then ZW 4 over X. Okay, that is your filled in statement of proportionality. This is super important. This is how I will teach you your trig, your 30, 60, 90, 45, 45, 90 reference triangles, or right triangles in trig. I will teach you this exact same way. And so if you master this and you understand what it is I'm doing, and you're able to get the scale factor in your head, you can essentially solve in your head. And you don't have to recreate all this writing, okay? So I use similarity to help me teach the trig. Okay, you filled it in. You need to solve now for our two variables or our two unknown lengths. Remember, we were able to figure out all 6 angle measures, right? Here's 4 of them because we were only given 2. So now we have to find the 2 missing side lengths. Okay, first off, your scale factor is the ratio, and you're always going to have one. If they don't give one to you, then that means it's not solvable. Your scale factor is the ratio that has 2 numbers. It's the ratio without a variable. So if you look at the first ratio, I have a letter. That's not my scale factor. If I look at the third ratio, I have a letter. That's not my scale factor. This here is your scale factor. It's number over number. So when I look at this, right, because that's my next question, what is a scale factor K constant of proportionality? Okay, well, we're solving small to big. So that's why we're going to get this constant. If you went big to small, it would be the reciprocal. Okay, so we're solving small to big. You have 3 over 6. So what is our K? Our K is 3 over 6 or 1/2, right? But if you solved big over small, I don't want to write it because I don't want to confuse anybody, but it would be 2 or 6 over 3, okay? Okay, so that's how you can start solving this in your head. So then you're like, oh, well, that's 18, that's 9, because I'm going to cut it in half. If this is 4, I'm going in the other direction, so I'm going to multiply by 2, that's 8. Right, but you have to do the work. Okay, so how do I solve for these unknowns? Cross product property. So CPP is how you solve. So if I'm asking you to solve for X and Y, you take the ratio with a variable, Y over 18, and you set it equal to your scale factor. Now you can write the 3/6, or if you want to reduce it and set it equal to 1/2, you can. And then all you do is cross product. And so what's Y is equal to 3 times 18 over 6, right? Now notice, I didn't go 6 over Y because I'm just going to have to divide the 6 out anyways, right? So if 6 goes into 18 3 times 3 is 9. Okay, so now try X. I'll put X over here. If I want to solve for X, I have 4 over X. That's one ratio. Remember, a proportion is 2 ratios set equal to each other. So if you have 4 over 6, set it equal to your scale factor. And it doesn't matter if you put the scale factor here, if you put it over here, it's fine. So 3 over 6. Okay, your X is a denominator. So you're going to go ahead and multiply and actually get the 3X. And 4 times 6 is 24. And then divide by 3, and there is my 8. So X is 8, Y is 9. But really, if I come back here, which one was 9? 9. This is now 9. So actually, WY length is 9, and MO length was the 8, right? And that's it. Okay, you have, let's see if I can even show it. I'll show it, but we're gonna, you guys, it just flew away. Yes, go catch it. I figured you want to see this. You can laugh. Oh, it's okay. Next video, just shoot at my house, right? Just at my house. Okay, similarity statement. Right, so we'll go through this. I'll upload it as a PDF, okay. All right, you guys, have a great day. This is a really long video, but I kind of added a ton more minutes of just the campus. Okay, bye. Okay, bye.